Hello and welcome to Diplomatic Derivatives. In today's video, we're going to continue the concept that we started in the previous video about applied mathematics, specifically the topic vector algebra. In this series of videos, we're going to talk about vector algebra and different concepts being scalar and vector products, differential operators, vector integrals, and vector theorems in the upcoming videos. Today's video is going to focus on the position vector. So let's see what a position vector is. Okay, so first of all, we're going to start with what is a position vector. A fundamental concept in vector algebra tells the position of a point in space relative to a reference point, usually the origin. So the concept here is that if we have some object on a table, let's suppose we have a pen, it's kept on a table in somewhere around the center, not exactly in the center, somewhere around the center, okay? Or it could be in the center, it just depends, right? So what is the position of the pen? We have to find its position in relevance to a corner, let's suppose. So that corner will act as the origin. We measure the distance from that corner of the table to the object, and the distance that we get is going to be its position on the table, right? That is the concept of position vector. So if we have any point P, all right, we have to get the position of that point, the location of that point, and that is done with the help of a reference point. And from the reference point we draw a vector, right? This vector will have a tail at the origin and head at the point. It's going to give us the direction as well as the distance, that is going to be the magnitude. Okay, that magnitude of the vector is going to be the distance of the vector of the object from the origin. All right, so this is the concept of a position vector. Okay, origin is obviously going to be 0, 0, and the point P, that is the position of the object, will have some coordinates in the space x, y, z. All right, now if we talk about 3D, if you have a point P, let's suppose x, y, z, and it is in 3D space, so obviously its vector, since it's at a point, right, and it's represented by a position vector. This position vector is going to be represented through some notation, right? Its representation is again similar to a normal vector. So in the previous video, we saw what is the representation of a vector, right? In 3D space, it's represented by, in the previous video, we wrote A1I, right? And A2J. Similarly, it doesn't make a difference. We can write xi plus yj plus zk. So this x is replaced by a1. So it's the same thing, some value on the x-axis, right? So it's going to be some value on the x-axis. Y is some value on the y-axis. Z is some value on the z-axis. I represents the unit vector along the x-axis. This represents along the y, and this represents along the z. Okay? This is for 3D space. Similarly, we have for 2D space, if we have a point P, it will be represented by x and y coordinates, right? So it will be xi plus yj. All right. Also, you can write in place of r, you can also write, since it's a point P, right? And it starts, the point P is somewhere in space. It starts from the origin, right? So the vector will be represented by vector O. Okay, so this is the vector position vector. Either you write like this or you write like this, it doesn't make a difference. It's the same thing. Okay, it's a position vector. Now we see some of the properties of the position vector. Direction, number 1. Points from the origin to the location of the point. So this position vector basically tells us the direction in which the object is located. Okay. Magnitude, distance from the origin to the point. So what is the magnitude? That is, magnitude of the vector tells us the distance of the object from the origin. Okay, so that magnitude of a vector is going to have a similar formula as we saw in the previous video. What is the magnitude of the vector? It's under root x square plus y square, right? So in case of 3D, it's going to be x square plus y square plus z square. This magnitude of the vector is basically what? It's a distance of the object from the origin. Okay, time dependent. In motion problems, the position vector can change over time. So what we're basically saying here is we're talking about motion problems. What do we mean by motion problems? Then that there is some movement. So if we have x and y coordinates and there is a point here, right? Then after some time t, the point moves from here to here, let's suppose, right? So in the first case, this is the position vector. When it moved after some time t, this is the position vector, right? So there is some time involved which changed the magnitude, because now this seems, and definitely the second position vector is bigger than the first one, right? So after some time t, that magnitude of the position vector increased, right? So also the direction changed, right? So it is therefore time dependent. All right, used in physics to describe displacement, velocity, acceleration, and forces. So it's used in physics for these purposes, to understand what is displacement, what is the velocity of the object, what is the acceleration at which the object moved, and what are the forces that are making the object move, right? This is all explained through position vectors. Now we're going to see for displacement specifically, that if an object moves from one point to another, what is the displacement, right? So how do we do that? That is a position vector between two points. Now let's suppose we have a point A, which is x1, y1, z1, and we have a point B, x2, y2, z2. So this is point A and that's point B. So we write this is point A and this is point B, right? Now if we draw the position vectors from point O, so what are the position vectors? This is the first position vector and this is the second position vector, right? So this first position vector is OA and the second position vector is OB. So how do we write the position vectors now? Again, it's simple, the vector representation. How do we do that? OA will be x1i plus y1j and z1k. Okay, make sure you add the caps on top of all the unit vectors, right? This is how you write the position vector OA. Similarly, you will write the position vector OB in a similar way. Just in place of x1, you will be having x2, y2, and z2 in place of x1, y1, and z1. And that's how you will write the position vectors for each point A and point B. Okay, so that's position vector OA and this is position vector OB. Okay, then the vector from A to B is, now what is the vector, this vector from A to B? That's vector AB, right? How do you represent that vector AB? So for that we use a formula which is position vector AB, which is basically what? It's the displacement. It moved from point A to point B, right? So we're basically talking about the displacement. And what is the formula for that displacement? That is, this position vector AB is equal to OB minus OA. Okay, that's the formula. Position vector AB, that's the displacement from A to B, will be OB minus OA. Position vector OB minus position vector OA. So how do you do that? You will write x2 minus x1i, that is to subtract x2 minus x1, and since they are from the x-axis, it's going to be I, plus y2 minus y1 j plus z2 minus z1 k. So basically what you're doing is you're just subtracting this vector from the first one, second one from the first one. So what you get is the position vector AB, which is basically displacement vector from A to B. Okay, we'll be performing some exercises for this, so it will be made clear of how you find the displacement from one point to another. Basically, you subtract the two position vectors, you get the displacement AB. Okay. Now we're going to see some examples of position vectors. How do you perform operations on position vectors basically? So in case of 2D, we have a point P. Now when you have a point P, what is the position vector? It will be OP, because the position vector starts from the origin, right? If you're given a simple point, we're not talking about any displacement happening, we're just talking about a point in any space, right? So its position vector will obviously start from the origin, right? So that will be OP, and that is represented here as R, right, which is 3i plus 4j. So whenever you're giving any point, you will just write it as 3i plus 4j, whatever point numbers are, right? Now what you do is you find the magnitude. You have to find the magnitude. That's the question. You have to find the magnitude of the position vector. How do you do that? You use the magnitude formula, that is under root, I forgot to put the under root here. So it's under root 3 square plus 4 square, right? So that's going to give us 5. That's the distance of the point. Okay, that's the distance of the point from the origin. Okay, so what do we get here? When we get the magnitude, what we're basically telling that this is the distance of the point P from the origin. Okay, make sure you remember that whenever you get a question and it asks you to find the distance of a point from the origin, what do? You find the magnitude of the position vector. Okay, you use the magnitude formula. Next is for 3D, same thing. What you do is first write the position vector, which will be OQ. We are just representing it as R because it shows that it's a position vector. It's basically OQ, that is from origin to the point Q. So how do you do that? Again, you find the magnitude. You have to basically tell the distance of point Q from the origin. So that will be 2 square plus minus 1 square plus 6 square. You get root of 41. This is the distance of point Q from the origin. All right. So that's how you do. You find the distance of a point from the origin. Okay. All right. So that's all for the position vector. Now we will be doing a lot of exercises for this, so all the concepts will be made completely clear. For this video, we're going to what we have done is basically understood the concept of position vector and what is its use. All right, now make sure you like, share and subscribe to my channel so that I could be able to make such content for you, to make concepts easier for you. And in the next video, we're going to talk about vector addition plus subtraction. That's also very important. We're going to cover the head to tail rule, which is again a very important concept. Also, we'll be talking about scalar multiplication and what is the use of scalar multiplication. Why are we doing scalar multiplication to a vector? So what happens when a scalar is multiplied with a vector? These concepts will be dealt in the next video. So make sure you stay tuned, and that's all for today. Thank you. Bye bye.